Hi, how are you all of you? Welcome to my channel Maths for All. So as I told in the last class, so now we are going to discuss about different forms of straight lines. In the last class we discussed about inclination of a line, slope of a line, angle between two intersecting lines, slope of x-axis, slope of y-axis, all those things we discussed in the last class. Now in this class we are going to discuss about different forms of straight lines. So there are nearly 15 forms of straight lines we have. 15 forms of different straight lines we have. So let us discuss one by one. So the first thing is very easy thing. The equation of x-axis. The equation of x-axis. So the equation of x-axis is y is equals to 0. Second thing, the equation of y-axis is x is equals to 0. The equation of y-axis x is equals to 0. So first two things are the equation of x-axis and the equation of y-axis. Why the equation of x-axis is y equal to 0? And why the equation of y-axis is x is equals to 0? Let me explain. It's a simple thing. This is x-axis and this is y-axis. Of course, this is negative x-axis and this is negative y-axis. As you all know, this is origin. If this is one unit, so this is the point 1, 0. So this is the point 2, 0. This is the point 3, 0. I think you know very well about this one. This is minus 1, 0. This is minus 2, 0, and so on like this. So once observe all these points. So all these points are on x-axis. In all these points, you observe this is y coordinate, 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 this is y coordinate. So in all the points on x-axis, the y coordinate becomes 0, but the x coordinate may vary. But the y coordinate becomes 0 on x-axis. On x-axis, in each and every point, the y coordinate is 0. That's why the equation of x-axis is y is equals to 0. In a similar way, so this is 1. So this is 0, 1. This is 0, 2. I think you know this. This is 0, 3. This is 0, minus 3. This is 0, minus 1. This is 0, minus 2, and so on like this. See, if you observe all these points on y-axis, in all the points in y-axis, the x coordinate becomes 0. So the equation of y-axis is x is equals to 0. The equation of x-axis is y is equals to 0. What is the reason behind it? In all the points on x-axis, the y coordinate becomes 0. In all the points on y-axis, the x coordinate becomes 0. That's why equation of x-axis is y equals to 0. Equation of y-axis is x is equals to 0. Right. So these are the first 2 points. So now we are going to discuss about third one and fourth one. What is the third one? The third one is the equation of straight line. The equation of straight line parallel to x-axis. Parallel to x-axis is of the form y is equals to k. Y is equals to k. And now the fourth one is the equation of straight line. The equation of straight line parallel to y-axis. Y-axis is of the form x is equals to k. X is equals to k. This is also very simple concept. But the thing is, here, what is k, sir? What is k? What it represents? This is very important point. Let me explain clearly. Again, this is x-axis, this is y-axis. Let us say this is 1 and this is 2. Now I am going to draw a line parallel to x-axis like this. See, Is it a line parallel to x-axis? Yes, why not? This is a line parallel to y-axis, sorry, x-axis. And see, this is 1 unit and this is 2 units. So the line is at a distance of, this line is at a distance of 2 units from origin. So this line is at a distance of 2 units from origin. So the equation of this line is written as y equals to 2. Y equals to 2. Why you wrote that like that, sir? Let me explain clearly. So this is the point 0, 2, right? This is the point 0, 2. Suppose if this is 1, so if you want to find out this point, this is 1, 2. See, this is 2, 2. This is 3, 2, and so on. Once again, if you apply the previous concept, so in all these points, in all the points which lies on this line y equals to 2, see, observe the y coordinate. What is the y coordinate? The y coordinate is equals to 2. So that's why the equation of this line is y equals to 2. Here what is 2? That 2 is the distance from origin. That 2 is the distance from origin. Suppose for example, this is minus 1, this is minus 2, this is minus 3. If I draw a line like this, so now the equation of this line is y equals to minus 3. Y equals to minus 3. So what is this minus 3? What we can say about this line? So you can say about this line like this. This is the line which is parallel to x-axis, and at a distance of minus 3 units. Is distance negative? Never. The distance never be negative. And how do you say it is at a distance of minus 3 units? We can't say like this. What we can say is that? Let me explain. So this is a line parallel to x-axis which is at a distance of 3 units. And it lies below the x-axis. So that negative symbol denotes the location of the straight line. If it is positive, then the line lies above the x-axis. If it is negative, then the line lies below the x-axis. So here what is k? Here k is the distance from origin. If k is positive, then the line lies above the x-axis. If k is negative, then the line lies below the x-axis. Suppose if I give a line like this, y is equals to minus 32. How do you describe about this line? You can select it. This is a line parallel to x-axis. Is it enough for that? No. So this is a straight line parallel to x-axis, sir. It is at a distance of 32 units from origin, sir. Is it enough? Not at all. You should say like this. This is the straight line parallel to x-axis which is at a distance of 32 units from origin and it lies below the x-axis. That is a perfect description of that particular line. Suppose if I write like this, y is equals to 99. What it represents? That is a line parallel to x-axis. It is at a distance of 99 units from origin and it lies above the x-axis. That is k. Very important. What is k? You should not say simply constant, sir. No. So k is the distance from origin. If k is positive, then the line lies above the x-axis. K is negative, then the line lies below the x-axis. In a similar way, the equation of straight line parallel to y-axis. So let's say this is 1 unit, this is 2 units. The straight line may be like this. Right. So this is the line parallel to y-axis and at a distance of 2 units from origin. Now this line is right side of y-axis. If it is right side of y-axis, you should take plus sign. If it is on the left side of y-axis, you will take the negative sign. So what is the equation of this line? This is the line parallel to y-axis. So then the line equation is x is equals to 2. What 2 represents? The line is 2 units from origin. Suppose if I write x is equals to minus 3, if I write like this, that is a straight line. This is a straight line parallel to y-axis at a distance of 3 units from origin. What is the negative sign denotes? The negative sign denotes that the line lies left side of y-axis, like this. Okay, above the x-axis, below the x-axis, right side of y-axis, left side of y-axis. These things are very, very important, right? What is the equation of x-axis? Y equal to 0. What is the equation of y-axis? X is equals to 0. What is the equation of line parallel to x-axis? Y is equals to k. What is k there? K is the distance from origin. If k is positive, the line lies above the x-axis. If k is negative, the line lies below the x-axis. What is y equal to k represent? Y equal to k is a straight line parallel to y-axis. Sorry, x equal to k is a line parallel to y-axis. What is k represent? K is the distance from origin. K is positive, that is right side of y-axis. If k is negative, that is left side of. Understood? Right. We will go for the next one. So now the point of fifth form of a straight line. That is, the fifth form is point slope form. The fifth one is point slope form. The name itself tells us it contains a point and it contains a slope. That is the equation of straight line. The equation of straight line passing through x1 comma y1 and having slope m is y minus y1 is equal to m into x minus x1. That is the equation of straight line passing through x1 comma y1 and having slope m passing through x1 comma y1. This is the equation of straight line. Sir, how do you derive, sir? Is there any proof, sir? Definitely there will be a proof for each and everything. Sir, how do you derive, sir? Is it tough? No. It is very easy. Let us see how easy it is, how simple it is. How do you derive? See what is given? Equation of straight line passing through x1 comma y1. See, there is a straight line like this. Let us assume there is a straight line like this. Now here is given this straight line passing through x1 comma y1. Passing through x1 comma y1. That means the point must lie on this line at anywhere on this line. The point must lie on this line anywhere. So let us take the line may be here. The line may be, the point may be here. So let us say this is the point x1 comma y1, because this line passing through the point x1 comma y1. So now if you want to find out the equation of straight line, let us take a point px comma y. So px comma y is any point on the straight line. He has got that the line passing through the point x1 comma y1. Right. So now there are 2 points on this line. If you know the 2 points on a straight line, definitely you can find out a slope by using the formula y2 minus y1 by x2 minus x1. In the last class we discussed about that. So what is the slope of this line? So slope is equals to, when 2 points are known on a straight line, we can find out the slope by using the formula y2 minus y1 by x2 minus x1. Now what is the slope of this line? y minus y1 by x minus x1. X minus x1. What is this? Slope. What is this? Slope. But what is this? It's a slope. So this is also a slope and this is also a slope of the same line. That means both are equal. So therefore y minus y1 by x minus x1 is nothing but slope. But he is given that the slope is m. Both should be equal. So just apply the cross multiplication. Y minus y1 is equals to m into x minus x1. Y minus y1 is equal to m into x minus x1. So this is the equation of straight line in point slope form, and this is the proof. See how simple it is. Very easy. Very easy. So what is the equation of straight line in point slope form? Y minus y1 is equals to m into x minus x1. Right. So let us discuss some applications of this point slope form. The application of point slope form, that is the equation of straight line passing through horizon. The equation of straight line passing through horizon. The equation of straight line passing through horizon, that is 0, 0 and having slope m. The equation of straight line passing through 0, 0, that is horizon, and having slope m is y is equal to mx. This is the equation of straight line. So passing through horizon, having slope m. This is the application of point slope form. Why you say that this is the application of point slope form? Because he has given the point and he has given the slope. Right? Both he has given. When the point and slope are given, we should just now derive now equation of straight line. Equation of straight line when point and slope is given, just now we derive. What is that? Y minus y1 is equals to m into x minus x1, isn't it? Y minus y1 is equal to m into x minus x1. Just now we derived. But in this case, the point is 0, 0. The point is 0, 0. Let us say this is x1, y1. Now instead of y1 0 and instead of x1 also 0, so just substitute here y minus 0 is equals to m into x minus 0, so that y is equals to mx. So this is the equation of straight line passing through horizon, having slope m. Just this is the application of point slope form. This is also very important. This is also the another form of straight line, that is 6 bar. But of course this is the application of point slope form. So what is the equation of straight line passing through horizon having slope m? Y equal to mx. What is m there? Slope. Okay. After this, we are going to learn about some application of this thing. We are going to discuss about the applications of this y equal to mx. Let's go for it. Applications of y equal to mx. Applications of y equal to mx. Right. The equations of angular bisectors of coordinate axis. What we are going to derive now? The equations of angular bisectors of coordinate axis. See, observe this one. Angular bisector. That means the angle is whose angular bisectors? Coordinate axis. That means the line must bisect the angle between the coordinate axis. Bisects means dividing into two equal parts. It's very important application. This is x-axis, this is y-axis. Of course, this is negative x-axis, this is negative y-axis, this is horizon. As you all know, the x-axis and y-axis are always perpendicular to each other. Of course, here also the angle is 90 degrees. Right. So now, there is a line like this. That line must bisect. That line, of course, this is straight line. That line must bisect. This line must bisects the angle between the coordinate axis. So, what is the angle between the coordinate axis? The angle between the coordinate axis is always 90 degrees now. Right. So now this line bisecting the angle 90. That means this angle is 45 degrees. Of course, this angle is also, this small angle is also 45 degrees. This angle 45 and this angle is also 45 degrees. Right. So now listen here. This 45 degrees is the, see, this 45 degrees is the angle made by this line with the positive direction of x-axis, right? This positive direction of this positive direction. So this line makes an angle 45 degrees with the positive direction of x-axis. Now, can I say 45 degrees is the inclination of this particular line? Definitely. If you know the inclination, can we find out the slope? Definitely. What is the formula? So if you know the inclination, you can find out the slope by using the formula m is equals to tan theta. So therefore, slope of this line, slope m is equals to tan theta. Here theta means 45 degrees. So m is equals to 1. M is equals to 1. Just observe, is this line passing through horizon? Is this line passing through horizon? Yes. Now, can you please tell me about y equal to mx? Y equal to mx? Just now I said that y equal to mx is a straight line passing through horizon having slope here. Now, what is the equation of straight line passing through horizon having slope 1? Equation of straight line passing through horizon having slope 1 is y equal to mx. So y equal to m means 1 into x is x. So the equation of this straight line is y equal to x. This is the angular bisector of coordinate axis. Sir, this angle is also for 90 degrees. Now, this angle is also 90 degrees. So there may be another straight line like this, sir. There may be another straight line like this. Yes, why not? Sir, this line also bisects the angle between the coordinate axis. Yes, why not? So this angle is 45 degrees. This angle is also 45 degrees. So this angle is 45 degrees. So can I say, is it the inclination? No, I can't say. I can't say because this is not the positive direction. This is not the anti-clockwise direction. So we cannot say this is inclination. Inclination means the angle made by the line with the positive direction of x-axis only. So this is not the inclination. Of course, this is the inclination. This line makes an angle. How much this one? So from here to here is 90 degrees and this is 45. Total 135. So total 135 degrees. So this line makes an angle 135 degrees with the positive direction of x-axis. That means what is the inclination of this line? 135 degrees. Don't say 45. Here 45 degrees, nothing. 45 degrees is not the inclination. But 135 degrees is the inclination. Remember why? Because this is the angle made by the line with the positive direction of x-axis. So therefore, what is the slope of this line? Slope is equals to, of course, slope m is equals to tan 135. So m is equals to, what is the value of tan 135? Minus 1. The value of tan 135 is minus 1. Of course, this straight line is also passing through horizon. This straight line is also passing through horizon. So the equation of straight line passing through horizon having slope minus 1 is y equal to mx. Here m means minus 1. So y equal to minus. So what are the equations of angular bisectors of coordinate axis? Y equal to x and y equal to minus x. You can say like this combinedly, y equal to plus or minus x. Y equal to plus or minus x. These are the angular bisectors of coordinate axis. This is a very, very important application of y is equals to mx. Very, very important application of y is equals to mx. What are the equation of angular bisectors? Means y equal to plus or minus x. Very, very important application. Right. We'll go for the next thing. Next, after point slope form, the next one is 2 points form. What is that? 2 points form. Again, the name itself tells us 2 points. 2 points. What is the previous one? Point slope form. In that we have point and we have a slope. Now this is 2 points form. So 2 points form is like this. The equation of straight line. The equation of straight line passing through passing through x1 comma y1 and x2 comma y2 is the equation of straight line passing through x1 comma y1 and x2 comma y2 is y minus y1 is equals to y2 minus y1 by x2 minus x1 into x minus x1. Y minus y1 is equals to y2 minus y1 by x2 minus x1 into x minus x1. This is called 2 points form. Of course, this is also the application of point slope form. What is the point slope form? Y minus y1 is equals to m into x minus x1. What is m there? Slope, right? So here the required straight line is passing through x1, y1 and x2, y2. No? Here the required straight line is passing through x1 and x2, y2, right? So when 2 points are known on a straight line, then what is the formula to find out the slope? Slope m is equal to y2 minus y1 by x2 minus x1. Just replace m there in a point slope form. Automatically you will get this one, y minus y1 equal to y2 minus y1 by x2 minus x1. Or otherwise, we may have another process for this. What is that, sir? Let me explain. Let us say this is the required line. He is given that the line passing through x1, y1 and x2, y2, isn't it? Right. That means the 2 point must lie on this line. Okay. Let us say this is x1, y1 and this is x2, right? Because the line passing through x1, y1, right? As usual, if you want to find out the equation of this straight line, we may take a point px comma y on it. Now, it is very clear that the 3 points A, P, B are lies on this line only. If 3 or more points lies on a same line, then the 3 points are said to be collinear, right? So then the condition for collinearity is, since A, P, B are collinear, implies the condition for collinearity is slope of AP is equals to slope of AB. So why don't we take slope of PB, sir? Yes, all the 3 slopes must be equal. Here, slope of AP, slope of PB, slope of AB, all the 3 slopes must be equal, then only they are collinear. Then why do you take these 2, sir? Because to derive this equation. Okay, so to derive this equation, slope of AB must be equal to slope of AB. There is no doubt at all. So what is slope of AP? A means x1, y1, P means xy. So slope of AP, so y minus y1 by x minus x1, that is slope of AP, is equals to slope of AB, y2 minus y1 by x2 minus x1, right? y2 minus y1 by x2 minus x1, right? So just apply class multiplication. Y minus y1 is equals to y2 minus y1 by x2 minus x1 into x minus x1. Y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1 is the equation of straight line in 2 points form, and this is the derivation of that. See how easy it is? And in this there is one more important concept, this one. If 3 or more points are lies on the same line, then the points are said to be collinear. What is the simple condition for collinearity? Slopes must be equal. There are 4 different conditions for collinearity. We will discuss later all those things. Okay, this is the proof of 2 points form. Clear? Achha. The next form is slope intercept form. What is that? Slope intercept form. What is that? Slope. You know about slope. Intercept. What is intercept? Achha. Do you know about intercept? Right. So if you want to derive of slope of intercept form. First of all, we should know about what is intercept. What is intercept? So first of all, we should know about intercept. So what is intercept? What is intercept? It's a very simple concept. If a straight line intersects the x-axis at some a comma 0. If a straight line intersects the x-axis at some a comma 0, then this small a is called x-intercept. This small a is called x-intercept. In a similar way, if a straight line intersects the y-axis at 0 comma b, because on x-axis y coordinate 0, on y-axis x coordinate 0. If a straight line intersect the y-axis at 0 comma b, then b is called y-intercept. Your intercept may be positive, may be negative. Suppose, for example, if a straight line intersects the x-axis at 3 comma 0, I said, then what we can say about the x-intercept? Here clearly we can say that 3 is the x-intercept of that particular line. Suppose, for example, if the straight line intersects the y-axis at 0 comma minus 99. If a straight line intersects the y-axis at 0 comma minus 99, then we can say that minus 99 is the y-intercept of that particular line. Minus 99 is the y-intercept of that particular line. In a reverse way, if 4 is the x-intercept of a straight line, I said, if 4 is the x-intercept of a straight line, then we can say that the straight line intersects the x-axis at 4 comma 0. The straight line intersects the x-axis at 4 comma 0. In other words, if minus 6 is the y-intercept of a straight line, if minus 6 is the y-intercept of a straight line, then what we can say? We can say that the straight line intersects the y-axis at 0 comma minus 6. Right. So now I have a question. What is the intercept? Is there any intercept? Is there any x-intercept for horizontal line? Is there any x-intercept for horizontal line? Suppose horizontal line is like this. Horizontal line means parallel to x-axis. Is this straight line intersect the y-axis? Yes, definitely. But is this straight line intersect the x-axis? No, never. This straight line never intersect the x-axis. That means there is no x-intercept for this horizontal line. So there is no x-intercept for horizontal line. In a similar way, there is no y-intercept for vertical line. The vertical line never intersects the y-axis. The horizontal line never intersects the x-axis. So for horizontal line, there is no x-intercept. The vertical line, for the vertical line, there is no x-intercept. Sorry, for the vertical line, there is no y-intercept. If a line passing through horizon, like this, for this line, is there any x-intercept? No. Is there any y-intercept? No. If a line passing through horizon, then for that line, there is no x-intercept and there is no y-intercept. This is about intercept in a simple manner. What is x-intercept? If a straight line intersects the x-axis at a comma 0, then a is said to be x-intercept. If a straight line intersects the y-axis at 0 comma b, then b is said to be y-intercept. For the horizontal line, there is no x-intercept. For the vertical line, there is no y-intercept. For a line was passing through horizon, there is no x-intercept and there is no y-intercept. Simple. It's a very simple concept of intercept. Right. So let us go for the concept. Slope intercept form. Slope intercept form. Right. So there are two forms here. The first one, the equation of straight line having having slope m and y-intercept small c is y is equal to mx plus c. And the second one, the equation of straight line having slope m and x-intercept small a is y is equals to m into x minus c. So many people knows about this line, but very few people knows about this line. But both are important. This equation of straight line having slope m and y-intercept c. This equation of straight line slope m and x-intercept small a. Right. Let us discuss. So let us derive both the equations. Let us derive the first one. So let us assume the first line may be like this. Right. So what he has given, the straight line, the equation of straight line having slope m and y-intercept c. Just now we discussed about intercept. So y-intercept c, that means the straight line intersects y-axis at c na? No. The straight line intersects the y-axis at 0, c, because on y-axis the x coordinate is 0. So let us say this is the point 0, c. Why? Because this intercept, this length, this value is c. Clear? So this is the point 0, c. Indirectly, he has given the point on the straight line. Whenever intercept is given, we know the point on that particular line. Remember. So this is the point 0, c. Now I am going to find out the equation of this straight line. So if you want to find out the equation of straight line, we have to take any point on the line. Let us say px, y. Let us say px, y. Right, it is very clear that there are 2 points on this straight line. If you have 2 points on a straight line, definitely we can find out the slope of that particular line. So when 2 points are known, we can find out the slope very easily. So the slope of this line, slope is equals to, what is the slope formula when 2 points are known? y2 minus y1 by x2 minus x1. See this, y minus c by x minus 0, that is x. Then what is this slope? But he is given that slope as m, so this should be equal to m, because that is slope. So cross multiplication, y minus c is equal to mx, so y is equal to mx plus. Y is equals to mx plus. So you can derive the slope intercept from y equal to mx plus c very easily. See how easy it is. Now let me discuss about the second one. The second line may be like this. What is the information he has given? So in geometry, the very important thing is what is the information he has given. What he has given, what we have to find out. These 2 points are very important in coordinate geometry. What he has given? The equation of straight line having slope m and x-intercept. What he has given? X-intercept a. So if you know the x-intercept, definitely point. What is this point? This point is a, 0. If the x-intercept is a, then the straight line must intersect the x-axis at a, 0. Again, we have to find out the equation of this straight line. So let us say this is the point. Let px, y is any point on the straight line. If you want to find out the equation of straight line, you should take any point. Right? So px, y is any point on the line. So it is very clear that there are 2 points on this line. If you know the 2 points on a line, definitely we can find out the slope. So what is the formula to find out the slope again? y2 minus y1 by x2 minus x1. So slope plays a major role. So what is the slope? Again, slope is equals to y minus 0 by x minus c. Y minus 0 by x minus c. That is equals to slope. That is equal to m. So therefore, y is equals to m into x minus a. I is equal to m into x minus a. So y equal to mx plus c is the equation of straight line in slope intercept form. Of course, y equal to m into x minus a is also the equation of straight line in slope intercept form. Here c is called y intercept, here a is called x intercept. Both are very important. This is the derivation. Achha, right. We'll go for the next one. And the next one is intercept form. The next one is intercept form. What is the previous one? Slope intercept form, and now intercept form. Let us discuss. The equation of straight line. The equation of straight line whose x-intercept is small a, whose x-intercept is small a, and y-intercept small b. X-intercept is small a and y-intercept is small b is x by a plus y by b is equals to. That is called intercept form of a straight line. Here a is called the x-intercept and b is called the y-intercept. So very important form of a straight line. Very important. Proof is also very easy now. Okay, what he has given? In this case, he has given both the intercepts. X-intercept is a, that means the straight line intersect the x-axis at a comma 0. Y-intercept is b, that means the straight line intersect the y-axis at 0 comma b. So the straight line is like this. The straight line intersect at x-axis and y-axis. So this point he has given a comma 0 because the x-intercept is 0. This point he has given 0 comma b because the y-intercept is b. Again, 2 points are known. So let us do the application of 2 points form. 2 points form, you know, no? Just now we discussed, we derived. Let us say this is x1, y1 and this is x2. And 2 points are known. He has given the 2 points on the line. He has given the 2 points on the line. So when 2 points are known, the equation of straight line. Equation of straight line in 2 points form. Equation of straight line in 2 points form. That is y minus y1 is equal to y2 minus y1 by x2 minus x1 into x. So the equation of straight line in 2 points form. So y minus, in this case what is y1? 0. Now y2 minus y1, this is b minus 0, that is b, by x2 minus x1, 0 minus, that is minus a into x minus x1. What is x1? A. Just simplified. This minus a1 is equal to bx, the minus ab, right? And now take this minus ay to that side and take this minus ab to this side. Then what will happen? This is bx plus ay is equal to ab. Bx plus ay is equal to ab. So divide throughout equation with ab. Let us see what will happen. Bx by ab plus ay by ab is equal to ab by ab is 1 now. So here b gets cancels, here a gets cancels. Finally, we got the equation of straight line as x by a plus y by b is equals to, and the equation of straight line is x by a plus y by b is equals to 1. This is the equation of straight line in intercept form. Okay, right. So in the next class, so we are going to discuss about very important forms of straight lines. Those are normal form of straight line, parametric form of straight line, symmetric form of straight line, and most important is general form of a straight line. In the next class, we are going to discuss about all these things, right? So if you like this class, please subscribe for more updates. Okay, so thank you very much.